Okay, I recognize not everyone might have been here from the very beginning, so let me just quickly introduce everyone on stage again. We have Lena Voita, who's a PhD student in two universities, University of Amsterdam and Edinburgh. Then we have Roberto Navigli, a professor at La Sapienza in Rome. To my right, you just saw him, Eneko Agirre from the University of the Basque Country. And to the very right, one of the co-organizers of this track, Jamie Henderson from IDIAP. And to kick off the discussion, so we definitely have to come back to Bert, right? Because it or he or, I don't know, was mentioned in each of the talks, so we'll have to discuss that. But I'd like to start with something a bit more general. Maybe in NLP, there are these two big streams, kind of the symbolic and the statistical, the connectionist. And Roberto mixed them. You had both the symbolic and the connectionist, but Lena and Eneko, you took more the connectionist view. Can each of you maybe give some thoughts on where do you think where is the truth? Is it a combination of both, or will one be able to emulate the other? Maybe we start with Roberto because he had them both explicitly in his talk.
Yeah, exactly. So that's my vision and my view. So to integrate the two things, I recurrently get questions about why are we still keeping integrating these two visions, because now we have BERT, now we have contextualized embeddings and so on. So this all this work on linking text to symbolic content might not be needed anymore. And my answer is very simple. I say, actually, in many cases, you need explanations. And you don't get explanations from latent representations. And even if you get such representations, they are not necessarily human readable or linked to content that comes from humans. So at the same time, you can, with lexical knowledge resources, you can intervene. You can provide guidance. Like, for example, when you start as a child, in many cases, you're not given examples, like a long list of examples. You're given basic information from which then you infer a lot of other things. And that's the kind of parallel, I think, to the knowledge that is integrated into neural networks, and that I think, is necessary. And also, scaling multilingually is easier, at least at this stage, if you integrate the two visions on a large scale. So, and finally, another thing that I think is very useful is when you deal with cases that are not like standard texts, but just, I don't know, lists of terms or different structures of textual content, then it's harder to apply just a neural approach.
What's your take, Eneko?
So, very good question, and I don't have an answer. I mean, I think it totally depends on the task. So sometimes we talk about NLP as if it was just one task, like the bot talking to us naturally, but there are many different tasks. We saw machine translation, but we also saw in the Bloomberg presentation, they were talking about entity linking. So you have New York, and you need to disambiguate whether you are talking about the New York Exchange, the New York City, the New York team, whatever. And there you need explicit symbolic representations. So in a way, when we are chatting together, we are interchanging symbols, not just the signals. So language is symbolic, that we know for sure. Now, there are many problems where there is enough data, so you actually don't need anything symbolic to fix it. Like neural MT is working very well, and you don't see any symbolic thing beyond. And then it's a useful tool. Now, somebody can say that for perfect machine translation, you actually need to have complete natural language understanding. But for complete natural language understanding, you need general intelligence, so you need humans. There are many cases which you cannot actually translate well unless you have full understanding of the human complexities. So at that level, everything that we can put into stock would be useful.
Jamie, you work on natural language understanding.
Yeah, so when you say symbolic, I would like to make a distinction between two aspects. One is the categorical effect, and I mean, there are categorical effects in language. Lexicons are categorical. But the other is that when we divide up our representations into a set of entities that are discrete, position 1 is different from position 2. There's no position 1.5. And Transformer has that. Even though you think it's all just vectors, there are discrete positions, and they're talking about linguistic objects, which are words, that's all been hardwired into the model. And so it's a misleading just say we have these connectionist approaches. Transformer is not a connectionist approach. It has discrete entities in it.
So we're seeing basically the convergence of the two paradigms.
I think we're seeing a convergence, yeah. I mean, learning discrete rules, we've given up on that a long time ago, but there is still a lot of symbolic representation left in what we're doing now. And I would even say more and more.
Mm-hmm. Mm-hmm. Lena, maybe I can chime in with like a plus question. Your talk was about interpretability a lot in these, it was more, I would say, reverse engineering what the model actually does and understanding. But do you think it can be pushed further into also give an understanding of the meaning, like something that can be read off by, say, a human analyst to understand why did the model make this or that prediction? Because at this stage, I think your research is mostly in the kind of what is even this machine that we invented conceptually doing?
Yeah, that's true. So I think it's a real problem with interpretability and reliability of current models, of course. And unfortunately, I don't have a solution of how to understand why, for example, BERT generated something or machine translation system generated something. Yeah, I have something to say about machine translation and why we still need statistical methods. For example, yeah, it's a complete mess with my affiliation. So my main affiliation is at Yandex Research, and most of the time I work on machine translation, and I collaborate a lot with Yandex Translate. And yes, neural machine translation systems work very well if you give it a WMT test set, if you give it like clean data. But if you have a translation service like Google Translate or Yandex Translate, you have users, you have like actual people who are trying to put their queries there. And it's nothing like WMT-induced translation test sets. And you end up having a lot of hallucinations and you need to care about them. And that's why, for example, at Yandex, we have like hybrid system, which is statistical and neural, because we cannot afford to show hallucinations to actual users. And there's a classifier which decides, so if a model hallucinated a lot, we'll show statistical machine translation, because we can at least interpret why it translated. So we have alignments, we understand that this word was translated in this way, and at least statistical machine translation, we can be sure that it's adequate enough. Mm-hmm. It's not fluent, but it's quite good. And if you are dealing with real applications, of course, the questions of interpretability and how reliable your model is, and can you trust that behavior in unexpected scenarios, it's really important. Mm-hmm. Yeah.
And at Yandex, since we're mostly academics on stage, but you have 1 foot, at least, I guess 1.5 feet, as you just said, in the industry. Are you using these models like BERT and Elmo already in production? I don't know if you can comment about this.
Yes, I know at least 3 places we are using them. So for machine translation, of course, it's Transformer. It appeared in production like 3 months before the paper, mm-hmm. after the paper, but it's still, as I said, hybrid system, a statistical one. It's an open information. I'm not going to get killed, don't worry. BERT is used. So recently Google released a blog post where they said that they're using a BERT in web search. They're not saying anything about it, but I worked as a data scientist at Yandex Searches, and Most of what you would want from BERT is some kind of similarity measure. For example, how similar is your query to your document, or how similar is your query to your snippet. And I assume it's something like that. And also it can be used in dialogue systems. We have, at Yandex, we have several scenarios where dialogue systems are used. So of course it's a voice assistant and Yandex Taxi. There's also dialogue system which helps you to communicate like users with drivers. And they're also used using BERT. So yeah.
I'm curious about everyone's opinions on kind of this pivot point where we are now with these pre-trained models, because one of the big differences I think now is that we can download the models from GitHub, and then we have them and we can start doing work with them. That's kind of a good thing, right? That we don't have to redo everything from scratch. But at the same time, we couldn't even redo it from scratch because it would take so many resources that we can't even verify pretty much whether that thing that we got is the best possible thing. So how do you weigh the pros versus the cons of that? And maybe what does it mean for practice, for NLP in the real world?
So what is the question again? So I mean,
the pros and the cons.
You mean the pros of the cons?
Pre-trained models.
So pre-trained language models are great. The pain is that you need so much hardware that most of the people in academy cannot even replicate what you said, experiments. The good thing is that they are releasing them. So you can continue doing other experiments. But that said, it's very dangerous to start a research program on producing better pre-trained language models, because in academy, who has the resources to do that? So that means that from the researchers, so from the industrial perspective, I think that's fine, because you can just use this and build your practical applications. Mm-hmm. There are many research projects that you can use it for doing dialogue or for doing question answering, doing many things. But if your research area is doing better pre-trained language models, then you have a hard time.
So in a nutshell, it's good for industry and it's bad for academia. What do you think, Jamie?
Yeah, I think there is some truth to that. For industry, they're more concerned about the relatively near term. Diversity is not such a huge issue. If it works, it works. For academia, I think diversity is very important. We can very easily, as a field, get stuck in local minima. And having one model and everybody uses the same model, and we don't even really know if that's an optimal in the space of models, it really cuts out a lot of diversity in the scientific inquiry. And at the moment, it's kind of bad to say, oh, we shouldn't just be doing engineering, since the field seems to be moving in that direction. But I think it's a serious concern. We need to increase the diversity of the scientific exploration, space of exploration.
There were other concerns about these models too that were actually voiced by OpenAI when they trained this GPT-2 model, and then they said we cannot release the model because it would be like an atomic bomb. Basically, we cannot let this loose on humanity. It would be too dangerous. People would be, I don't know, generating fake news from it. How realistic is that real? Was that honest, or was it just a way of copying out from publishing a model?
It's a very difficult question. Can I go back to the other question and then maybe connect? We
put it on the stack.
Well, connect to this. Okay. So, in a sense, what is happening now with contextualized embeddings and transformer and so on, and the power that is required, the amount of resources that is required, is similar, to my opinion, but in a different respect, with what happened with information retrieval. So we don't have the billions of searches that big companies have to do large-scale research in information retrieval, for example, but while big companies have. So the risk of this is that it's true that the academia will always come up with new approaches and solutions that are independent of the business need, but it's also true that we need to be careful not to give up on producing new solutions that unfortunately require huge computational power. So connecting to this point, I think I read an article two days ago about the things that GPT-2 and other approaches cannot do. And actually, in a sense, in that article, and also in my opinion, it's more like a super ELIZA. So it can perform a lot of tasks, much more intelligent compared to ELIZA, but still not showing the human intelligence that we would like to see in a computer, and maybe we are wrong. So I wouldn't be so concerned as long as we can see what the limits are and what can be done in the future.
Does anyone want to speculate what can catapult us beyond ELIZA?
No, I don't. I don't know what ELIZA is, but about my fault. Yeah. So I wanted to. So I have a funny experience of trying to use something like GPT-2 to actually generate. Well, it wasn't fake. It was. So in Russia we had like a birthday of a very prominent Russian author these days, Gogol, and we were asked to so when PR wants to do something cool, they asked for some reason research department. So I was asked to write a story based on a prompt given by a modern Russian author, but with the style as Gogol would write. And we trained like a huge language model using all data we had in Russian, on Russian literature. We fine-tuned it on Google. And so I was feeding like prefixes from this prompt given by this modern author. And it's really far from being reasonable. It's really far from being reasonable, because I spent like 24 hours. I didn't have much time. I spent like 24 hours feeding prefixes, generating like 20 versions, picking one of them, like, okay, let's start from this part again. And yeah, so it's really, even if you have a lot of data in trained language model, it's still really far from humor.
We have just a few more minutes left, but I want to pick up one theme that we also saw at least twice during this session, cross-linguality. What do you think is the importance of cross-linguality? Not only from a very technical, as it's a challenging problem and so on, of course, but for society, does it matter? Can it help us protect small languages, for example? Can it democratize the web? Or are we just doing it because we can, because it's an interesting research problem?
Well, I think it can help democratize the web a lot, because if you can access content that you couldn't read otherwise in different ways, you don't necessarily need to translate. You can do a lot of things, but if you can rephrase or summarize or translate into your language, or vice versa, your language into another language, I think it will help preserve the diversity of languages, rather than, obviously there's also the risk that everything would be translated or converted into, a standard language, but also vice versa. So I think it will help set a level playing field in a sense.
I'll pass the question to you also, Eneko, and I'll add a slight add-on question. How feasible is it really even what are the limits of machine translation? There are cultural aspects also. If we can now translate everything among all pairs of languages, how close do we get, how much of a substitute is that to learning the other languages? But you can also just ignore that question if you want.
Okay, so regarding your last question, so machine translation is always going to be a substitute for human understanding. I mean, There's no way. So I agree with Lena when she said that some text cannot be translated because the machine has been trained with some particular texts. So usually formal translations. So the machine is going to be able to understand other contexts and is not going to be able to produce good translations in those contexts. So we shouldn't confuse the utility of a tool like machine translation with the final goal of a full, complete natural language understanding and completely good translation in any circumstance. So that's one thing.
Jamie.
Well, yeah, the multilinguality is obviously of huge practical importance for inclusion, for example, but it's also a fundamental scientific issue in linguistics. You can't really have linguistics when you have one language. It wouldn't be possible. You have the diversity of languages is really huge. It's unimaginable in many ways. And that gets at fundamental cognitive issues about the nature of language is presumably closely tied to the nature of thought and therefore to all of AI. So it really, without the diversity of language, it would be much harder to understand, to solve the AI problem.
So every language is basically just one data point.
It's a different data point about the nature of cognition.
Yeah.
So it's really fundamental.
We are close to the end, unfortunately, but I would maybe like to do as a finishing sweep one round where you can just maybe each reflect or muse a bit about where the field has come, where is it going, and maybe to make it a bit more concrete, what is the change that you've seen from the last 5 to 10 years to where we are now, and where will we be in, I'm not asking for 50 years because that always asks for very wobbly answers. Where will we be in 5 to 10 years? And maybe we can just start this way.
Okay, I have a problem with 5 to 10 years because 5 years ago, it was the moment I decided to do something about machine learning, because before I was interested in pure mathematics, and unfortunately you're not going to get paid if you do pure mathematics. That's why I switched to some to more applied things. So yeah, but in the last 5 years, I think I say that a lot has changed. For example, in the field of machine translation, there used to be statistical machine translation systems for a long time, for a really long time, from like 2007. Yeah, and now it's really fast. I don't know what you're feeling, but I feel like it's getting really fast to keep track on what's going on. So yes, really, it's hard to imagine what's going to be in 5 more years. I have no idea.
I hope not. But my opinion is that in 5 to 10 years, we'll have working natural language understanding systems in multiple languages. And the key issue above semantics, that is common sense, pragmatics, will be started to be addressed in an interesting way, I guess. So because that's the next key thing. So as also Eneko said, so in order to really understand, you need also to understand what's around, what's in the world, and what things imply. And so this is lacking at the moment. So I think in the next 5 to 10 years, beside improvements of NLU systems, there will be this part to be strongly addressed.
So I hope Roberto is right. I would love that common sense and natural language understanding is the key thing in the following years. I'm not very optimistic because they are really hard problems. So I mean, they are really nice for researchers, but I don't know if they will have an impact in real applications. But I wanted to give a complementary view, is that I think actually multilinguality and cross-linguality are going to be a big thing. So for several reasons. One is that now we have better tools to break the barriers between languages, thanks to machine translation, but also these multilingual pre-trained language models. And also because I think the market of the big companies, they are really interested in many languages. So for instance, my Android telephone is working in Basque. I guess that most of you localize your Android telephone to work in your own language. and this is dozens of languages. So Basque is a minority language, it's not a big language, and still Google took the effort of localizing the most of the Android to Basque, which is great. I think these big companies, because of their self-interest probably, because they want more customers, but still they have a big interest in multilinguality. And many of the data sets which are being created in the last year, I would say, from big companies, they are addressing this gap. So you had a squad for English, and now they are releasing data sets for cross-lingual question answering in other languages. And the natural language inference you had for English, and now it's for like 10 languages. They are also addressing the cases for languages with less resources, not all of them, but at least they showcase. For somebody like me who has been doing research on natural language processing with an eye on low resource language like our own Basque, I think this is going to be a very interesting time for this. Yeah, I think in the near future, I'm also a bit skeptical about common sense reasoning, but it's perfectly plausible. We will be moving farther and farther up the kind of abstraction hierarchy towards more complex, more contextualized semantic representations, farther from words. But as you do that, the supervised learning paradigm really breaks down. I mean, the NLI and all the problems that people have found with the natural language inference data was supposed to be a general purpose semantic resource. In fact, it's hugely biased and all based on fairly fixed patterns and not really learning about much at all about semantics. So the supervised paradigm is really breaking down, and we really need to be using much more of an unsupervised paradigm, which is one of the reasons why Eneka's work is so interesting, that to bridge the gap and move into those higher levels of semantics, we really need to do unsupervised learning. And the other big trend is obviously, the computational architectures. Transformer is really a radically different architecture. And I think that still has a long way to run.
Great. So the summary that I draw is that there's a lot that already works if you're out there and want to get stuff done. But if you're an academic and you are looking for research problems, then there's also still a lot to be done. So we all win. Let me thank all of you in the audience, and thank again all the speakers and co-organizers that we had. I think it was a great afternoon, and hope to see you around and next year for sure.